Right.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to our first ever Western Canadian Organic webinar series. I'm thrilled to see such interest in this series we put on this winter. I think we had 134 registered today, and we've got a good group already joining in. So I hope all is well out where you're listening from. I am Chantal Jacobs, and I work in Regina for Sask Agriculture. So today I'll be chairing your session, and I'd also like to extend a big thanks that goes out to Laura Telford with Manitoba Agriculture and Carrie Sharp with Alberta Agriculture for helping make this whole series happen. A lot of good ideas came in from them as well. So today's presentation, as most of you know, will be our second organic webinar in the series that we're doing. And the next two we're actually hosting will be scheduled again over the lunch hour, and the next one will be on February 11th. It's called Growing Hemp on the Prairies. And then on February 18th, we're doing one called The Plant's Role in Soil Fertility Management. So if you haven't signed up for those, or you might have some interest, just look for the links or send me a quick email, or just let me know and we can help you get signed up for those. So just some background housekeeping stuff. Our presentation today will be about an hour in length with the opportunity for questions at the end. So what we'll do is we'll have Dr. Gallandt. He'll do his presentation, and we don't want you to lose any of your questions, so please enter them into your questions box or your chat box. That should be on your GoToMeeting thing there, and enter them in, but we'll just let the presentation go on, and then we'll get to them at the end of the webinar, and hopefully have a good discussion through chat at that time. Everyone is muted right now, so if you're yelling at me that it's not working, I'm sorry, I can't hear a word you're saying. I hope it is working for everyone fairly well today. And if you are viewing the webinar from a computer with dial-up, you may experience a delay in the audio or the slides. It is being recorded, so everyone should receive a link after the webinar that about an hour after the webinar is completed, so that you can go back in and have a look at the recording and see anything you missed if you had to step away. If we have technical issues on our end, our system's usually pretty good, but you never know what can happen. The power can go out unexpectedly. Just please stay online and we'll get reconnected as soon as we can, so just bear with us. Okay, so that's pretty much it for my end. So at this point, I would just like to, extend a warm prairie welcome to our presenter, Dr. Eric Gallandt. He is the Associate Professor of Weed Ecology and Management at the University of Maine, and his research includes ecologically based weed management. It looks a lot at organic farming systems and basically all things relating to weeds and managing them using an ecological approach. So we're thrilled to have you here today. And if you've heard anyone mention a guy who talks about using the many little hammers to manage weeds in a systems way, you've come to the right place. Dr. Gallandt is the guy you've been looking for. So without further ado, and a warm welcome from all of us, Eric, I'll hand it over to you and let you get going.
Very good. Thanks a lot, Chantal. Just to orient you all, so I am from Maine. It's a small developing state in the northeastern U.S. Not typically a place you think of when you think of agriculture. If you look at this vegetation cover map of Maine, you see all of the green is forest. And so you might be wondering, what is an agronomist doing in Maine anyways? Well, we do have a couple of large ag industries. So we have about 40,000 acres of potatoes up here in Aroostook County, 20,000 acres. You can see the red. So the red is agricultural lands. 20,000 acres of low bush blueberries. And then all along the coast, we've got our important fisheries. My work in Maine, I primarily work with Maine's organic farmers. We have 380 certified growers in the state. Mostly diversified vegetable growers are my clientele group, but also some dairy and grain growers. And these growers are concentrated mostly in the southern part of the state, as you can see by the dark green circles. And their primary production problem are annual weeds. And if you think about managing annual weeds, one of the more important things to think about is the seed bank. Annual weeds, they rely on the fact that they produce a lot of seeds and that at least some of these seeds are able to persist over time. And much of my work is focused on both thinking about controlling weed seedlings, but more a broader perspective of thinking about managing the weed seed bank. And when we think about managing the seed bank, we have to think both about opportunities to eliminate or minimize credits to this bank. So we try to reduce weed seed rain, and good weed control does that, as does crop competition. In diversified vegetable systems, we have the opportunity sometimes for short season crops to preempt seed rain, seed credits. In systems where you're using winter grains, sometimes winter cereals or winter grains can preempt seed rain from our summer annual weeds. And then we also think about debiting the seed bank through trying to manipulate things like decay or predation or germination. In terms of managing weeds, annual weeds, organic farmers are typically relying on cultivation, some sort of mechanical weed control. And there are really two major problems with this reliance on cultivation. And the first is that the efficacy or the proportion of weeds controlled is highly variable. This is a data set just from last summer where we went out to 70 locations in a 5-acre field, and we put down a quadrat, and we had overseeded the field with condiment mustard. So the weeds in this case were a surrogate weed. Behaves a lot like wild mustard, only it's uniform in size when we do our trial. And then we cultivated this field. We had our farm manager do this with the single, that 4-row cultivator I just showed you with Danish S-tie. And so we had the same cultivator, weeds of the same size, a surrogate weed, and you look at the huge range in efficacy. So we killed anywhere from 0 to 100% of the weeds. The average here was 56%, but in 25% of the locations, the efficacy was below 50%. So highly variable. And to be honest, we don't really know the sources of all this variability. Some of it we think might be related to soil conditions. But anyways, this is just part of what we're living with when we're dealing with cultivation. The second major problem with relying on cultivation is that the efficacy or the effectiveness, it's constant over a wide range of weed densities. You know, we'd like to cultivate and kill 100% of the weed seedlings there. We don't do that. And moreover, we don't kill an increasing proportion with an increasing density. In other words, the efficacy is the same over a wide range of density. So you're killing about, in this case, 69% of the weeds down in this area where the density was low, as well as in areas where the weed density was much higher. And what this ends up meaning is that the density of survivors increases with the proportional to the initial density. So, in other words, if you start off with a seed bank that is moderate to low, so we do a lot of work with weed seed banks by we take soil cores like this, a known number of cores, and we spread them in greenhouse flats, water them, and just simply count the density of germinable weeds. And if you started off with a situation like this where you have a seed bank density of, say, 1,000 germinable seeds, you say 5% of those turn into seedlings, and then you apply that 69% mortality that we just did with the tine harrow, say, you end up with 16 surviving seedlings. And then that's still probably quite a few, so that would be 16 seedlings per square meter. So you would cultivate again, kill 69% of those, and end up with 5 per square meter. And that might be an acceptable density for you. But if you take another situation, say a field or a farm where the weed pressure is considerably higher, in this case, here's some soil cores where the seed bank density would be closer to 10,000 germinable seeds per square meter. Again, say 5% establish, and then you get your first tine harrowing event kills 69% of those. You still have a high density of survivors, so you cultivate again, kill 69% of those, and you still have too many weeds. So basically, with increasing seed bank densities, people end up having to increase the intensity of their cultivation proportionally. And not that this is wrong, it's a very simple way to address weed problems. But it doesn't leave you with a situation where weed management improves over time. And the weed pressure varies highly across organic farms. These are some examples of soils collected from farms in northern New England. In 2010, we sampled 23 organic farms in Maine, New Hampshire, and Vermont. Mostly diversified vegetable farms, but probably a third of these would have been dairy farms growing grain and pasture. And there were relatively few of these farms where the germinable seed bank, so that's what's on the y-axis here, ranging from 0 up to 30,000 germinable seeds per square meter. Very few that I would call low, so below 3,000. Quite a large number that I would consider this sort of mid-range, so 3 to 10,000 or so. And then quite a number here that would be extremely high in this, 25,000, close to 20,000 germinable seeds per square meter. Now again, if you are in this sort of situation, it just simply means that you're going to have to cultivate more, kill 70%, you have 30% survive, and you just keep doing that until you get a density of weeds that is acceptable. However, the question that I've worked on for quite a number of years is what should we recommend to farmers that would like to see their weed management improving over time? And that is where we start thinking about this multiple stress approach to managing weeds, or like Chantal said, the many little hammers idea. And this is something that my friend and colleague Matt Liebman and I wrote about, it's been about 15 years ago now. And the general idea here is to reduce the emphasis or reliance on controlling weed seedlings. It's not to say that we're not going to cultivate, or if you're in a diversified system, maybe using herbicides, but rather than putting all of our weed management effort on seedlings, we think about the many stresses that we could impose by enhancing crop competition to reduce seedling biomass. That then reduces weed seed production and weed seed rain. Are there other strategies that could be done to enhance seed loss from the soil surface, so predation of seeds or decay of seeds? Or a potentially important strategy is to actually manipulate the establishment of seedlings. This is, I suspect it's probably not so useful in much of the prairie, but if you've got a long enough growing season, the idea of creating a stale seed bed by encouraging germination losses from the seed bank, getting those seeds to germinate and establish, because they're vulnerable here. They're easy to kill at the seedling stage, they're very difficult, if not impossible, to kill directly when they're in the seed stage in the soil. So that's the general idea. This is a list here of some of the hammers. There are many things here that I'm sure you've heard of. The general categories I would describe as strategies to enhance competition. So you can look through there and see crop species, cultivars, seed size, and so on. General strategies to reduce seedling density, and again, we're not going to get rid of cultivation. That's still going to be an important part of a diversified management program. But one of the things that we would emphasize more is thinking about seed density and strategies to reduce weed seed density. So what I'm going to focus on today is sort of three different, stories or examples that I tried to pull from work that I've done and some from colleagues in Northern Europe that I thought would be particularly applicable to the prairie. So I didn't want to emphasize the diversified vegetable examples that I have here. Anyways, focusing on competition and strategies to enhance crop competition, which is really pivotal to good weed management, cultivation strategies, and then lastly, seed bank management strategies. So starting with crop competition, as I suggested, it's really foundational to an effective weed management programs. If farmers are using herbicides, cereals are generally sufficiently competitive. They tiller. It's very easy to maintain crop yields. But in the absence of herbicides and with increasing weed density or weed pressure, it's important to think about managing to increase crop competition, and crop density is probably the foremost approach here to improving competition. This is a classic data set showing increasing wild oat density and relative wheat yield. So you can see you have high spring wheat yield here with no wild oat, and you add one wild oat, and here at a spring wheat density of 10 plants per square foot, you get a reduction in the wild oat, or a reduction in the wheat yield, and the second wild oat reduces the wheat yield more on up until it starts to sort of slow down a bit, and you get some maximal amount of yield loss. So you can see that 2 wild oat plants per square foot, the dramatic increase in crop yield that you can achieve simply by increasing the density of the crop. And you can see it going up to an extremely high density. This would be pretty unusual. You get some additional benefit, certainly it's about 1/4 there. But this is really illustrative of the principle of having high crop density for increasing competition. One of the things we've noticed around working with our grain growers is that growers are still often planting based on seed mass. So they're planting, 2 bushels of seed per acre or some number of pounds per seed per acre. And it's really important to consider the actual desired target population that one would want.
Hi, Eric. Sorry, it's Chantel here. We're getting a fair bit of echo on your mic all of a sudden.
Okay.
I'm not sure if anyone else is. Am I echoing for you?
No, you sound fine to me.
Okay,
I'm echoing now.
Yeah, you're echoing quite a bit. To the point you're getting very faint, and it's kind of hard to hear. So everyone says it's just yourself that's echoing. So of course,
I assure you.
Yeah. Oh, actually, that sounds better now. Whatever you just did, that sounds better.
All right. So
you're good to go.
That's okay now?
That's okay now, yeah.
All right. I don't think I changed anything, but maybe I clicked open some box on my computer, and maybe that's good enough.
You're good now from what I can hear.
Okay, I'll try to not touch any wires or anything. So, anyways, I think the point of this was to remind me to talk about the need to, plant our cereals and other grains to some target populations and not just consider the massive seeds that one is putting out in the field. You can see that to reach a target population here of 45 seeds per square foot, you need almost 200 pounds of this large seeded Harvard cultivar compared to almost half that for this small seeded red Fife. And so if people are seeding just based on pounds per acre and not taking into account seed mass, you really may not have any clue as to what your total population is. And then on top of that, you should consider the germinability or viability of the seeds. And then on top of that, there's the just error or the variability in your seeder or drill and its ability to get seeds into good seed-soil contact. This is a data set from a few years ago with one of my graduate students where we knew exactly what our target stands were for. These are a number of different cereal weed management systems that I'll talk about a little bit later. But if you just look at this would be a standard density of spring wheat in this case. And these are all of the plots that she measured her actual plant stands relative to her target population. And you can see that it was quite variable, but overall the average was just barely above 80%. So this was taking into account the viability of the seed mass, and then we even overseeded 10% to make up for, the estimated 10% loss of stand. And you can see that in each case, in 4 of our 6 treatments here, we were below our target stands, despite our best efforts. In these 2 systems, we actually were above our target stands, primarily because this was a different drill. This was an air seeder that, for whatever reason, it worked better, and the extra 10% that we added got us above what we were even hoping to achieve. So the point is that you may have to plan on poor stands, or at least think about adjusting your seeding rate to accommodate for that. Now, establishment is affected by a whole number of things, including your drill and soil conditions. Seedbed preparation is really important. Not to say that you have to go to the extreme of making something that looks like this, but it also has to be a reasonable seedbed. So that's the first point I guess I would wanted to make, was thinking about density and making sure that people realize that just because we're putting more seeds out into the field doesn't necessarily always mean that we're reaching the high populations that we need in order to get that weed management benefit of enhanced crop competition. The next example related to competition I wanted to tell you about has to do with managing arrangement. So it's easy to increase density. It's quite a bit more difficult to manage arrangement, but it could be done, and there's some evidence that it could be a very powerful way to improve crop competition. This idea came from a friend and sabbatical host of mine, Jake Weiner at the Royal Veterinary University in Denmark. And what Jake came up with the idea that he's more of a traditional plant ecologist, and his thinking was, well, why is it that we plant our crops in these rows where they're really crowded in one dimension, but they're not crowded in the other dimension? So basically, we have this clump in a long, narrow line. If there are no weeds, then the cereal plants are able to tiller and grow, and they take up the space in between the rows, and it's not a big deal. But if weeds are present, this clumped pattern reduces the ability of the crop to suppress weeds. And Jake was able to work with some really clever ag engineers at the Royal Veterinary University there to come up with a precision seeder that allowed him to plant cereals very precisely in 2 dimensions, so nicely offset here. So really achieving a very nice uniform plant pattern for the cereals. Here in this diagram, I've made some of them bigger and smaller just because there's slight variability in the rate which they establish, but in general you get the idea. And he did a really nice set of field experiments comparing then more traditional ways of sowing. So cereals sown in rows, clumps like so. So there's your cereal crop. And then the weeds are shown here, the white circles. And then you can see what it looks like here. So there's the crop. And versus his uniform sowing with this precision seeder. And now, keep in mind that, this precision seeder is not something that this is for experimental purposes, but you get the idea. So you can see the nice uniform pattern to the wheat here. And then he seeded, hopefully you can see the mustard here. So he used condiment mustard, very much like I did in some of those cultivation trials, as a surrogate weed. So it comes up all at one time and is very easy to work with. And here you can see the density. So same density, so a high density sowing of wheat grown in rows in the top, and you can see the yellow mustard flowers giving you a sense of the density of those flowers, density of those weeds, and then in the bottom, the uniform sowing, and you can see quite clearly the reduction in the number of yellow flowers there. Interestingly, we actually have a grower, one of our organic growers in Maine attempts to achieve this by planting cereals in 2 passes that are sort of oblique to one another. And I recently met a couple of New York grain growers that are trying to approximate this uniform sowing by putting 1/3 of their seed out the front of the tractor with a broadcaster and then 2/3 out of the drill. But anyways, you can see this is Jake's data here, and you can see the total weed biomass, and he did this uniform versus rows at 3 different wheat densities. You can see in each case the weed biomass was lowered by having the uniform planting pattern. And the general idea here is that when the weed emerges, it's going to be more likely in a uniform pattern to encounter a crop plant, whereas when the cereal is planted in rows like we typically do, the weeds are going to be as likely to come up in a inter-row area and have no competition from the crop early on. And then this is just showing that there is a yield advantage that was corresponded with that uniform sowing. So again, this is not, it's not that somebody's going to, on a large acre, go out and build a precision seeder to get exactly the equidistant or uniform sowing that Jake achieved, but working on techniques or equipment that could approach this could offer some advantages. Another area that my Danish colleagues have worked on quite a bit over the years is fertilizer placement. This is another important strategy for improving competition in organic systems. It's been long known that placement of mineral fertilizer down below the soil surface, where it's going to be preferentially available to the crop and avoid availability to weeds, is a good idea. They've done some work on this with manures as well in Denmark. So this is showing the deeper injection of hog slurry in this case. And again, the idea is, our annual weeds are germinating mostly from the upper couple of centimeters. So if you broadcast apply nutrients, in particular nitrogen there, it's basically can help break dormancy and help to offer your weeds luxurious nutrients. Whereas if you place the manure or the nitrogen or the fertility source down in a band, you're going to offer preferential access to the crop and reduce the access to the weeds, giving the crop an advantage. And show you here some data from Karsten Rasmussen showing relative to broadcast application of slurry, so broadcast set at 100, weed biomass set at 100%, comparing the slurry injection, reduced weed biomass compared to the broadcast plus harrowing, so harrowing reduced weed biomass compared to broadcast, but then here's the combination of injected manure, so resource placement, as well as harrowing. So you can see the reduction in weed biomass by managing competition combined with reducing weed density and the corresponding increase in crop yield here. So that's all I wanted to talk about in terms of competition. The next section I wanted to focus on was related to cultivation. And I'll focus mainly on strategies that could be employed in cereals. So I'm not going to talk too much about row crops. Most often, people are using in organic systems tine harrows, which are very fast and inexpensive, very high efficacy if the conditions are ideal. Ideal conditions for this tool are very dry soil and very small weeds. So these would be considered small weeds. You see these two weeds on the right are what we'd call in the white thread stage. So this is red root pigweed and common lamb's quarters. And over on the left, these weeds, although they're only in the cotyledon stage, they're actually quite large for a tine harrow. You can see the impressive root biomass that this is wild mustard and hemp nettle, Galliopsis here. So the efficacy of these in good conditions with a tine harrow could easily be high 95% or so, 95% or above. The efficacy, even with these that we typically measure, is going to be more like about 70%, 75%. So this white thread stage is important, and if you can nail it, it's awesome, and everybody goes out and buys tine harrows. But if it's a little too wet and the weeds are a little bit larger, it's not going to work so well. Generally, people are doing this pre-emergence and then perhaps 10 days after planting, depending on emergence patterns, and then perhaps again another 7 to 10 days later to control yet another flush of weeds. When I first was introduced to the tine harrow, I remember using it post-emergence in cereals and having our farm manager tell me to just drive like crazy and don't look back and don't come back for a week. And I thought, oh, isn't that great? And he also said, make sure you increase your seeding by 10% or so. So we would typically do that. What I've learned since is that despite effective weed control with the tine harrow, there may not actually, there are occasions when there's not actually a benefit to crop yield. This is partly a function of, perhaps the density of weeds was too low. Perhaps the efficacy was poor due to timing or the size of the weeds. But thirdly, it could also be this direct damage to the crop. So here are just 3 examples. I could find some others where you did get weed control and an advantage to crop yield. But the point is that just because harrowing's giving good weed control, it doesn't necessarily mean that it's going to be manifest in improved crop yield. This is partly because if you look at the change in crop yield with increasing weed control with a tine harrow, basically in order to get higher levels of weed control with a tine harrow, you have to be more and more aggressive. So that means more crop burial. And when you get more crop burial, you start to have a negative effect on crop yield. And then you get some positive effect on crop yield because with improved weed control, you're reducing weed density. But then what you end up in the combine or in the bins is some sort of some effect here. So you've got to balance overall this negative effect from damaging crops with the positive effect of reducing weed density. And it's a fairly complicated, it takes a lot of experience and knowledge to do that. One of the things that some growers in Northern Europe have started to do, some organic growers that were not satisfied with the with tine harrows and also have more perennial weed problems than we have here, is looking at actually growing cereals in wider rows and using an inter-row hoe. So basically the idea is that the cereal is grown more like a row crop, and you can use a very aggressive wide sweep and has a efficacy on a much larger range of weeds, so you don't have to worry about white thread stage weeds. You can kill very large weeds. You can control. You have a wider range of opportunity for using the cultivator. This field of wheat was actually cultivated that day that I took the photograph, and this is Paragroup organic grain grower in Denmark. So you can cultivate quite large cereals. And as I mentioned, the other advantage that some of these growers see is that they can get some control of their perennial weeds. So the hoe is something that we've done a bit of research on. I have a former PhD student, Lauren Kolb, who did some work comparing actually the strategies to increase crop competition with the strategy to improve cultivation by hoeing. And she did this using 3 different treatments. So she had, this would be, she would have the standard treatment with 200 plants per square meter, which is about 100 pounds of barley per acre, 500 plants per square meter, again with this time only in narrow rows, and then she also had a wide row system that she was able to cultivate. And the standard system, so this would be the 7-inch rows plus is with a tine harrow. We compared the 2 alternative systems. So this would be improving crop competition with narrower rows and higher density and tine weeding versus the wide row hoed system. And you see that both of those in 2 years of study, this is in organic barley, performed better than our standard system, which is what most of our organic growers were doing. Lauren also worked in using the same kind of system in spring wheat, and again comparing a standard drill with again a 7-inch row spacing plus tine harrowing to an increased seeding rate, narrow rows. So this would be this narrow in this case would be 4.3 inches, or a wide row system which is 9 inches plus hoeing. All of those systems end up reducing weed biomass compared to our standard treatment. One of the things that surprised me initially was when we looked at the economics of these systems. So here we see, this is just for the wheat experiment, that the net income actually was greater for this wide row system. And this surprised me initially until we looked actually at our production costs, and it was the first time I really looked at what we were paying for organic seed. And so when you have to buy organic seed, these high seeding rate treatments are a whole different deal than I realized. And that suddenly, investing in a machinery one time, and then the production, the per acre cost was relatively low for this inter-row hoe. And then really favorable yields in that system end up making it be, for us, the most profitable system. And it also perhaps has some reason to look at just in terms of being more robust over time. It's going to be a little bit less sensitive to weather. So overall, with just summarizing some of these competition and physical weed control studies, in barley, we found that the increased seeding rate and increased narrower densities or more uniform sowing, both of those strategies improved our weed management relative to what our growers were doing with a standard 7-inch row spacing and tine harrowing. But the economic performance of these depended really strongly on both the severity of weeds. So, just as you would expect, if weed pressure is low, it doesn't pay to spend more money on seed, nor does it pay to run a hoe. But if weed pressure is high and the price of seed is low, then elevated seeding rates would be very cost effective. But if you're buying the seed, then this hoeing system would be something to perhaps think about. And we saw similar results for our spring wheat studies. So again, increasing seeding rates gave us improved weed suppression, but generally with greater costs. And in this case, this was for bread wheat, and we were having trouble with our protein with the higher densities. And with the wide row system, we didn't see any yield penalties. We had higher protein in this system and actually better net returns. We did a little bit of work looking at the nitrogen mineralization inspired by the hoeing, but it turned out to not be a consistent effect for us. The final section that I wanted to talk about, this is some of the core of my work in recent years, has been related to managing weed seed banks and in particular managing seed predation. This is an example of it's fairly common in diversified vegetable farms. Here's a late season winter squash, and you can see the abundance of lamb's quarters and pigweed here and the seeds there that are contributing to the weed seed rain. And a very typical, solution to this problem is you simply harvest the squash and then disc and chisel and disc and then plant a fall cover crop and poof, it's beautiful. It's just like, it's all that mess is gone and it looks so nice going into the winter, which is true, and it's great to have a cover crop going into the winter. I don't want to hate on cover crops, but the disturbance that is associated with these fall cover crops from a weed ecology perspective basically takes the entire weed seed bank, which was concentrated right at the soil surface, and buries most of the seed, thereby protecting those seeds from animals that are looking to exploit this, really a highly nutritious resource. The same reason we eat seeds. It shouldn't be surprising that in any agroecosystems you look at, there are animals out there that want to eat seeds. In Maine, our predominant seed predator is this ground beetle, Harpalus rufipes. Yours may be rodents or granivorous birds or other invertebrates. We did some research both on farm and at a research station comparing tilled fall cover crops to a no-till system. And the rationale here is that no-till fall cover cropping would keep the weed seeds at the soil surface where the animals could eat them. And we tested this with these cages that you'll see here. And the idea would be that by putting these cages, we protect the weed seeds within that cage so the animals can't eat them. And so next spring, when we took soil samples, we would expect to find abundant weed seeds inside the cage and relatively fewer weed seeds outside the cage because the animals have eaten them. And you can see in the first year of our experiment, this is the germinable seeds, and then inside the exclosure, we had 28,800 seeds, and outside the exclosure, pretty much the exact same number. Basically a complete bust. And we're like, okay, what happened to all of our seed predators? We did the experiment again, and you can see that inside the exclosure we have 62,000 seeds and 42% fewer outside. And so a very large predator effect here in the second year of the study, and we were, of course, elated, making a big deal of this. And unfortunately, we repeated the experiment a third year, and you can see that identical inside and out, no predator effect. So we're really still trying to figure out what is going on with our seed predators, whereby in some years they can have a really large effect. You know, if this would have been 12% in this year, I'd probably just give up on the seed predation stuff. But when the predators are really active, they can have a very large effect. What we don't know is why it is in certain years we're not seeing an effect at all. Is it space? Is it the interannual cycling of the predators, you know, like rodents cycle over time? We really don't know. We've got some work going on to try to figure out what are the source of that variability. But one thing that I will note is that the no-till system, at least from my cooperating farmer's point of view, this is Rob Johansson, he saw no downside to this. And this is like we had a sort of a freak early warming in April and a big flush of lamb's quarters. And Rob here is really thrilled because, you know, in this no-till system, the seeds were all at the surface. They responded to cues to germinate. And then he's basically going to till that field and control those weed seedlings before he plants. So basically, he just had a large depletion of the weed seed bank based on this sort of unfortunate germination event. So there's probably not a downside to this kind of strategy of maintaining weed seeds at or near the soil surface. I thought I'd finish up with just a brief story also featuring Rob. He uses a flamer in the fall of the year to kill potato vines and basically was interested in something a little bit more reliable than our seed predators. And so he started to basically slow down his propane flamer in the really weedy sections of the farm, basically saying that he was going to fry all the weed seeds. And we did some work looking at the weeds that were both standing in the farm, and you know, although it looks pretty satisfying to see this blackened pigweed, when we looked at the viability of the seeds without flaming, so minus or plus flaming, there was really no significant effect. So this was also true with common lamb's quarter. So these standing weeds, the flaming really wasn't doing much to it. But we did some work with seeds on the soil surface, and here we have red root pigweed that was either not flamed, or this would be the typical propane dose, so 1.6 mile per hour is what Rob would use to kill potato vines, and those seeds were still viable. But if he doubled the dose by halving his speed, he basically could pop the pigweed. So here we have sort of popped pigweed, which actually I think you can get that at health food stores. So anyways, this is something that, you know, is certainly not going to be useful on really, really broad acres due to the cost, but in small areas where seed bank management is really a priority, or in high value crops, it's something that people could look at. It's been interesting to follow that, you know, around the world, people are looking at different strategies to improve seed bank management. So the Harrington Seed Destructor has developed basically a sort of a rotary mill, not really a hammer mill, but some sort of milling device that basically the combine chaff runs through this, and the weed seeds and chaff get pulverized and then spread back out, so that the seed viability ends up being, you know, reduced by 95% or so. This has been inspired by herbicide-resistant lolium, ryegrasses. I haven't seen much about this other than what I've seen on the web. I'm hoping that maybe somebody in the audience could tell us if they're actually using this Canadian innovative system. I haven't found any papers published on it, but the few reports online make it look like a very interesting system. Again, using combines as giant seed predators. And then finally, one last example that I just came across from Sweden, basically sort of an innovative mowing device used in a tramline system to try to eliminate weeds, reduce weed seed rain, reduce biomass of perennial weeds. So there you have it. Basically, competition is really foundational, and it's even more so in crops where you have limited opportunities for physical weed control. So any of the strategies that can be done to improve the competitive effects on weeds is going to typically not only increase crop yield, so that's the competitive response, but it also, the competitive effect is what is really important. How much is that increased stand density reducing weed biomass and thus reducing weed seed yield, weed seed rain, because that's what ultimately starts to help improve weed management over time. One of the little hammers that is contributing to a cumulative effect of multiple stresses on weeds. Cultivation efficacy is unfortunately highly variable and often lower than we would like. We want to keep in mind that, in particular with things like blind cultivation, like tine harrows or rotary hoes, that the need to balance sort of the benefits of improved weed management or reduced weed density with some damage to the crop. And so the old adage of just don't look back and go fishing for a week is probably not so helpful. And then ultimately, more clever ways, if people want to put the management inputs into the system, strategies that reduce seed banks are really what's key if you want to see improving weed management over time. Ideally, one of the strongest factors here can be diversification, so winter and spring crops, or in our systems we have the advantage in vegetables of having the opportunity to put some short season crops in a rotation, and something that's very short season can both offer opportunity to preempt weed seed rain because the crop comes out before weeds go to seed, but also can have some timely soil disturbance that encourages germination losses to the weed seed bank, and an important debbiting mechanism. So there you go. A little bit more information. There's some of this stuff that I've talked about available on our really cool YouTube site, Zero Seed Rain, and a few things available through my university website. So, got 6 minutes for questions.
Thank you, Eric. That was a great presentation, and I think got our group really thinking. We have a few questions in the queue here, so what I'll do is I'll read out some of the comments, and maybe I'll do some of the comments first. I've got one in here from Gary Martins. He says he's from the University of Manitoba, and he said, I followed the McLeod harvester for a number of years, but the company did not succeed because not enough farmers bought the system. However, it was very effective in reducing seed return to the seed bank. So that was
Thanks for that one.
Yes, thank you, Gary. I've got another fellow here. In springs when the weed, this is from Colin Lundy, in springs when the weeds get a head start, some farmers swath the flowering weeds above the young cereals. Is there any research on the efficacy of this?
I don't know of any data sets where people have looked at that specifically, but clearly you're going to reduce the amount of seed rain relative to having not done that. So one of the things that we've noticed is that if you do it too early, then the weeds basically have a chance they sprout at the side shoots, and then you still have seed rain. So doing it as late as possible would be the best idea. But I think that's the idea with that comb cut system that they're looking at in Sweden. So I would expect that we'll see some data on that fairly soon.
Mm-hmm. I think Eric Johnson did a little bit of work on that as well, doing up here at Scott, Saskatchewan. So I can't remember the results, whether it was effective or not. Maybe someone in the group can remember from one of Eric's presentations. Joseph Bourgault also said he has developed a 6-inch seed boot and he seeds on an 8-inch spacing, so he maximizes the spreading of seeds so that there are no rows or very little. He calls this 6-inch seed boot the Bourgault tillage maximizer for anyone who is interested. And I think he had a follow-up comment I saw there just saying that when you were showing your two photos with the clear rows and then you had the more widespread distribution of seed, that his was the bottom photo. I think he's referring to that he gets really, that good distribution of seed across the seed bed.
Yeah, there's some nice work from the UK where they've done that, and I wish we would have had the equipment to have used like a scatter shoe with the wide rows, so you'd sort of have this combined system where you have sort of these wider, high-density rows, but then still some hoeing in between those sort of scattered bands of seed.
Right. And then Milo's just asking, Milo Chubb, could you explain what you mean by narrow and wide rows? Do you mean the actual row spacing or the seed spread per row? So, again, similar.
Yeah, that would be the row spacing. So we were calling narrow 4.3 inches, and then we basically plugged every other opener to get a 9-inch spacing for our wide row.
Right. Okay, I think that's, from what I can see, that's most of the seed spacing questions. I've got another question actually that came in right at the beginning. My apologies, Don. Don Blay says, Canada thistle is our major weed. What control methods are available? I'm sure many people ears perk up when they hear that Canada thistle mentioned.
Yeah, that's a tough one. I mean, it's basically that there's nothing new for Canada thistle besides, attempting to time your disturbance and then crop competition. There's one tool that they came up with in Denmark called the Kvikkup, Kvikkup, which is basically like a big rototiller sort of machine that attempts to disrupt the below ground roots and bring them up to the surface. But it's a powered implement, so it would be very costly on large acres. So it's basically timing of disturbance when you can, and then crop competition. Okay.
And I had one more, I think, up at the top here. Would moldboard plowing, how would that do to bury the seed bank help in seed decay? Sorry.
Yeah, so plowing is actually a great strategy, and depending on the weed you have, you can, if it's a long-lived seed, you can only do it once, though, because you plow it, you bury the seed, and then you plow it the next year, and you bring them back up. But we've done some work with crabgrass, and moldboard plowing crabgrass gave us the same next year's, same subsequent year's seed bank as a hand-weeded treatment. And crabgrass seed is just not very, very persistent. So if it's annual grasses, it's probably worth trying. If it's mustard, I would try it. Or do it once, but then don't plan on plowing it back up.
Okay, yeah, you're getting that kind of washy effect again. I'm not sure why. Who knows with these systems, Eric? But hopefully, if we keep chatting, it'll sort itself out. We have another question just in from Curtis Brown. What about the use of poultry as custom grazing seed predators, maybe only in a small scale?
Can you hear me now, or is it?
It's pretty fuzzy yet. Yeah. So. Not sure why there.
It's such a bummer because I haven't changed anything.
Yeah, that's not too bad. It's still there you go.
I don't have any data on poultry. That's a great one. The only data sets I know about are weed seeds and poultry manure, which tend to be very low viability, presumably because they're going through a gizzard. But I've never done the experiment. I don't know of anybody that has, put out a known number of seeds and then had the, released poultry to graze on them. It's a great idea for a study, though. I know my own chickens do not leave any seed that's as large as a wheat seed or bigger. They find 100% of them. So I don't know how small they would go.
Right. Yeah. Something to try, I think, there, Curtis. Let us know how it goes. All right. Well, we're looking at just a minute after 1 here. So if there's any last-minute burning questions, just fire them in.
Yeah, and people could feel free to email me as well. I think that, I don't know if you post that, but if they Google Gallandt, Gallandt, at the University of Maine, you'll find me, so.
Right. Actually, I just have a couple more comments that just came in. Colin again said just made him think of quackgrass as a vegetable grower. Quackgrass is an issue. He's tried plowing before a freeze to try and freeze the rhizomes, but has not seen great results. Do you have any comments on that?
Yeah, the people that are having the best luck with quackgrass are tending to try to do like the 14-day intervals of tillage, 2 or 3 times in the spring, and then again 2 or 3 times in the fall if they can, and using we call it a perfecta-harrow, but it would be like a light field cultivator, something that attempts to lift the rhizomes to the surface. So it's really that timing of you want to disturb the rhizomes at an interval that prevents them from reestablishing and photosynthesizing and replenishing the below ground food reserves. So that's what that kind of 14 to 21 day interval is, where that comes from.
Great. Another comment from Curtis Peters. He said, just a comment on controlling wild mustard. I've direct seeded my hay, and then I clip the mustard, which is his main weed, just as the seed pod is coming on, and then after each time, the amount of seeds that form in the mustard is significantly less. He said you cannot harvest the first year hay this way, but it works well. So, yeah, just a comment there. So, sorry guys, I'm just trying to scan through. I think we're getting to the tail end here of comments. Looks like we're kind of getting to the end. So I guess we'll wrap it up here, Eric. And thank you everyone for your wonderful questions and thoughts on what's worked out there for you as well in the field. So there'll be a short survey, of course, after you exit the webinar, and this is where it's a great chance for us to get some feedback because it's just a small group doing some planning here this year, and we'd love to hear what your thoughts are and ideas you have for future ones. Anything you say, of course, will be held confidential. And I would also just, again, like to remind everyone that our next couple webinars coming up will be on February 11th and the February 18th. So the first one will be on organic and conventional hemp on February 11th, and then the next one on February 18th on soil biology processes. So thank you again very much, Eric, for your time today and all your thoughts and comments. That was excellent. And
sure thing.
Thank you everyone on the line for joining us, and have a wonderful rest of your day. Take care.